question 2, GCE 2023 paper 2. Question 2 in this paper was about geometric progression. So the question says, in a geometric progression, the second term is 21 and the fourth term is 189. Calculate the first term and the common ratio, the sixth term, the sum of the first 5 terms of the progression. So for us to solve this question, we need to remember what a geometric progression is. So a GP is a sequence that is like this one. You see that for you to get the next number, you have to multiply 2 with a certain number. For you to get 18, you have to multiply 6 with a certain number. For us to know the number that we are multiplying with, you can divide 6 by 2, 18 by 6, 54 by 18. You find that the number that we are multiplying with is the same, R. So in this sequence, common ratio is 3. Okay? And then from the same sequence, we have what we call the first term. All these numbers are referred to as the terms. So we have the first term. The first term in this case is 2. And the first term is represented by letter A. So in this sequence, the common ratio, the number that we are multiplying with to get the next number, is 3. Then the first term, the number we are starting with in this sequence, is 2. So from there, we go back to the question. We are taught to find the common ratio and the first term. Meaning, there is this sequence in this form, okay, where there is the first term, which we don't know. And then we are told that the second term is 21. We don't know what the third term is. We are told that the fourth term is 189. So our job is to find A and the number they are multiplying with in order to get these terms in this sequence. The next thing that we need to remember is the formulae used in geometric progression. So we need the formula for finding the nth term and the formula for finding the sum of given terms. So the formula for finding the nth term is Tn equals ar to the power n minus 1. So n stands for the term you want to find. If I want to find the second term, then n will be 2. So I put 2 there. If I want to find the 10th term, then n will be 10. Then the formula for finding the sum is Sm equals first term, open brackets. If the ratio is greater than 0, then we say r to the power n minus 1 over r minus 1. If the ratio is less than 1, then we swap this. We say 1 minus r to the power n, 1 minus r. So to answer question Roman numeral 1, that's 2a Roman numeral 1, where we need to find the first term, which is a, and the ratio, common ratio, which is r. We are going to form equations using the information that we are given, and we're going to use this formula. So we are taught that the second term, so where there is n, I put 2, is equal to, where there is n, I put 2. The second term is given, it's 21. We don't know a, so we still use a. We don't know r, we still use r. 2 minus 1 is 1. So when the power is 1, we don't write it, we just write it like that. So this formula is for finding the second term. I can even swap them. AR is equal to the second term, which is 21. Then the other information is that the fourth term is that minus 1. So, okay, so we are still using this. I've substituted n with 4. Even here, I substitute n with 4. So this will give us the fourth term. We are told that it's 189 equals, we don't know a, we don't know r. 4 minus 1 is 3. So this equation will help us to find the fourth term. I can rewrite it as this. Okay, so from the two equations we formed, we can name this as equation 1, then this one as equation 2. From those two equations, we'll be able to find the value of a and the value of r, or the common ratio. So I can bring them here. So 2a1, we are finding the first term and the ratio. So I'll bring those two equations, r AR to the power 3 equals 189. Then AR equals 21. Here I'm going to divide. So I'll divide AR to the power 3 by AR and 189 by 21. When I divide this will cancel, giving me 1. Then here I'll remain with R to the power 2. So you can bring in indices here. A is common, the common base, the powers are 1. We have 1 there, we have 1. So it will be 1A to the power 1 minus 1, giving us A to the power 0, which is 1. With R, we have the common base, so we subtract the powers. R to the power 3 minus 1, giving us R squared. So that's where this is coming from. Then 21 into 89 is 9. We are looking for R, so we cannot leave it here. We need to get rid of the square, and we do that by introducing the square root both sides. So R squared, the square root of R squared equals the square root of 9. So that this square cancels with the square root. We remain with R. Then the other side, the square root of 9 is 3. And since we are dealing with the square root, we have the square there, meaning we have positive or negative 3. So we have two solutions there. This means, according to the information we are given, we are dealing with two sequences. One sequence has got the ratio which is positive 3. The other one has got the ratio which is negative 3. Okay, so for us to find the first term, we can either choose positive 3 or negative 3. So if you choose positive 3, make sure all the questions are answered with positive 3 as the ratio. If you choose negative 3, make sure that all the questions are answered using negative 3 as a ratio. Okay, so we go to A2 where we are finding the first term of A. So I'm going to use one of these equations. I can get the first one, which is AR equals 21. I know R. Remember we said R equals positive or negative 3. So if I get positive 3, I have A, substitute R with positive 3 equals 21. A times 3 is 3A equals 21. Divide both sides by 3. This will give me A as positive 7. So if my ratio is positive 3, then the first term will be positive 7. So 2A2, we are finding the 6th term. So the formula or the equation for finding the nth term is this one. Tn equals AR to the power n minus 1. We've calculated A, we've calculated R, so we can substitute where we say Tn is equal to 7. Then we have positive 3 to the power n minus 1. So this is the formula for finding the nth term in the sequence that we are dealing with. So to find the 6th term, I'll simply make n to be 6 and then substitute in this equation. So T6 equals 7, 3 to the power 6 minus 1. T6 equals 7. Please don't multiply at this stage because this 3 is raised to a certain power. So first deal with what you have in brackets, then you multiply with 7. So I'll have 3 to the power 5, or 6 minus 1 is 5. Then I have 7. 3 to the power 5 is should be 240. Then we can now multiply with 7. So T6 is equal to 7 times 3 is 21. Carry 2, 28, 29, 30. Carry 3, 14, 15, 16, 17. So the 6th term in this sequence is 1701. We go to 2A, Roman numeral 3, where we are finding the sum of this progression. So I said the formula for finding the sum of the GP is Sn equals first term, open brackets. When the ratio is greater than 0, we say R to the power n minus, R to the power n, then minus 1 over R minus 1. So the data we have is that A is positive 7, R is positive 3, then n, we are told to find the sum of the first 5 tens. So n will be 5. Then we substitute. Sn, also it be S5 equals 7, open brackets, 3 to the power 5 minus 1, close, over 3 minus 1. S5 is equal to 7. We've calculated this, so we're just recalculating. This gave us 243 minus 1 over 3 minus 1 is 2. S5 equals 7. This will give us 242 divided by 2. Okay, let me bring this here. So I have S5 equals, we can multiply 7 times 2 is 14, carry 1, 28, 29, 14, 15, 16 over 2. S5 equals 2 into 16 is 8, 2 into 9 is 4, remainder 1, 2 into 14 is 7. So the sum in this sequence is 847.